We're going to continue. This is the the practice quiz that we already posted, so we can go ahead. So we did the problem number 1. Just in number 2, there are a couple of tricky ones that we have to do it. Okay, that's a practice quiz number 3. Just evaluated each integral. So we go with the number 2. Okay, number 2. This is exactly the one that we posted. So would like you to evaluate, or this is number 2, evaluate each double integral. Evaluate the double integral on the given double integral. And the domain is already given to you, okay, on the given region. On the given region. The first one is a polynomial type. I set it up and just do it yourself. Okay, so the part 1, I call it part A. So the part A is just a polynomial type. It's a double integral on R, and you have 129 minus 4x squared minus 5y squared, and the dA. The domain is given to you as, I just want to make sure you're familiar with the notation, 0,8 cross 0,8. Okay, so it's a rectangular domain. This means x is between 0 and 8, and y is also between 0 and 8. Okay, x is between 0 and 8, and the y is between 0 and 8. So just the integral, if you don't want to repeat it, we call it I. So you set up in this format. The order is not going to be important for this one because it's a rectangular one. So we go 0 to 8, 0 to 8. And then you have 129 minus 4x squared minus 5y squared. It doesn't matter going with the x or going with the y. So if you go with the dy dx, that is going to be the way you set it up. Okay, so that gives you just the rectangular domain, integral respect. I just do one part and you continue doing it yourself. I integrate respect to the y, so that gives you 129y minus 4x squared y, and this is going to be 5y cubed over 3. So the y going from 0 to 8, and then when you're done, you're just integrating respect to the x. Okay, so it's not going to be a big deal, but it's going to be quite a lot to find. So you just continue taking this one yourself. Nothing special about this one. Okay, any question? You know that replace the y by 8, you get a polynomial in terms of the x, and then you're integrating. That's a part 1. Now, the part 2 is the one that you get quite a lot to do. Okay, so that's going to be part B. The integral in question is this one, a double integral on R. The function is x sine of x plus y dA. And the domain is going to be again a rectangle, but the rectangle with this information, 0 and pi 6. So this means your x is between 0 and pi 6, cross your y is going to be between 0 and pi third. Okay, you got to be patient for this one. We have a couple of these when we go on, even if you go to the triple. So let's set up the integral first. So the solution is going to be, you read it here that your x is between 0 and pi 6. Okay, and your y is between 0 and pi third. Okay, so the integral in question now is going to be, we write it as I is equal to the double integral. So we have the x sine of x plus y. You decide which one goes first. Okay, for this one, as you can see, you better go with the y first. because sine of x plus y easily would be cosine. If you go with the x, you have to use okay, integration by parts. So eventually we have to, but we leave it a little bit, we do it later. So that's why I go with the y first and then the x, because it's a rectangular region. So we can, the order is not going to be important. And then you can go with the order that you feel more comfortable. So I go with the y first, so it's going to be 0 to pi third, then it's going to be 0 to pi 6. Okay, so decide how we're going to operate with your integral first. Any question? So what we're going to do, we are going to integrate respect to the y first. Okay, so we take this part first. If you take this part, this would be constant. You're just integrating sine of x plus y. Integral of a sine is just a negative cosine. You're not going to worry about u prime because u prime is 1. So this is going to be your first step. So it's going to be integral from 0 to pi 6. So it would be negative x cosine of x plus y. Integral of a sine, negative cosine. Okay, and then you are going to change the y. So your y going from 0 to pi third. Okay, 0 to pi third, and then whatever we do, we come back and we integrating respect to the x. To be precise, you put a parenthesis here. Any question? Carefully substitute, replace the y by pi third here. So it's going to be 0 to pi 6. Okay, and you have a negative x cosine of y pi third, so it's going to be x plus pi third. Okay, x plus pi third minus when you put the y equal to the 0. So that gives me minus x cosine of the x plus 0. Okay, then you did the x. We have another one that is, instead of the pi third, it's a pi half. That would be easier to handle, but not this one. It's not bad. I just put it so that you know that you have to be patient to get this integration. So what we are going to have is nothing almost to simplify. And of course, we are not going to, distribute this one. If it was a pi third, pi half, pi, we do it, but keep it as is. Don't try to distribute it. Okay, so what you are going to end up is this 0 to pi 6. Okay, so there is going to be a negative. It's going to be negative x cosine of the x plus pi third. Okay, and this is going to be a positive x plus x cosine of x. Okay, so this is going to be the integral that you have to handle. And that is going to be the case. So I'm going to break it in two parts, integral of the first one, second one, and then work on it. Okay, it's integration by parts in both case, and it can be, okay, it can be done. Yes, so this is a situation that we are going to have. Okay, so I'm going to break it in two parts, the first part and the second part. And you need kind of two integration by parts to be able to do it. So the integral would be changed or would be break into these two parts, negative 0 to pi 6. Okay, that would be x cosine of x plus pi third dx, and the other one is integral of the x cosine of x dx, 0 to pi 6. You need the integration by parts for both of them. I just give you one and we take you one of them and then we can copy for the second one. Okay, so let's check this one first, 0 to pi 6, and that would be x cosine of x dx. You have to do integration by parts. Of course, we do it in the short form. We call it, the tabular method. Use the table to do it. Remember, the way we do it with the table is this one. You go with this table, this is going to be the sine, and this is going to be the x, and this is going to be the cosine x, the short form. So we put the sign, I'm sorry, and this is going to be the sign. You differentiate here, and then you integrate here. So we go with the positive sign. We put the x here, the cosine x here, and then we continue. We repeat this procedure. The sign would be negative. The derivative of x would be 1. Integral of a cosine would be sine. Then we continue to get the 0 on the first column. So this is going to be positive. The derivative of 1 would be 0. And integral of a sine would be negative cosine. And the way we are going to collect the information is going to be this one. Okay, a shortcut from calculus 2. So the integral is integral from 0 to pi 6 x cosine x dx is going to be equal to, you multiply these two together and the sign positive, so that gives you x sine x. Okay, that's it. It's going to be x sine x, and then a minus, you multiply these two together, that give you negative cosine x. Okay, and that's it. So everything from 0 to pi 6. So basically this is going to be x sine x, and that gives you a positive cosine from 0 to pi 6. Any question? So substitute. So that gives you pi 6. Okay, pi 6 sine of the pi 6, and that would be plus cosine of the pi 6. When you put the pi 6 and then you put the 0, that gives you 0. Okay, plus cosine of 0. Pi 6 is going to be 30 degrees. So you see the sign is 1/2. It's going to be pi 6 times 1/2. And the cosine is radical 3/2. Okay, and the cosine of the 0 is 1. So that gives you minus 1. So this would be pi 12. Okay, pi 12 plus radical 3/2 minus 1. Okay, so that would be the result of the first integral. Okay, any question? So I just remind you that this a type of method that you can use. Now you can copy this one for the second one, because everything is the same except that you get this x plus pi third. So I can say that similarly, just write it down. You can finish it yourself. So the second part is going to be integral from 0 to pi 6. Okay, you have the x, the cosine of x plus pi third dx is going to be similar one to this, because the derivative of x plus pi third would be just x again. So it's going to be like the one that you got over here. Okay, so this is going to be x. It's going to be x sine of x plus pi third. Okay, and plus cosine of x plus pi third. Then you have to evaluate it from 0 to pi 6. Okay, 0 to pi 6, which is not going to be difficult to find, because if you substitute, this is going to be, you can finish it yourself, but if you put the pi 6, that gives you pi 6. That's a sine of the pi 6 plus pi third, which is a 90-degree sine is 1. And that would be the cosine of, okay, pi 6 and the pi third, which is going to be cosine of the pi half, which is 0. And if you put the 0, that gives you 0 here. And this would give you cosine of the pi third. Okay, so not a big deal. This is the pi half. And this is the pi half. So that would be 0, that would be 1. So you arrive at the pi 6 plus 0. And this is going to be minus the cosine of the, okay, the cosine of 60 degrees, which is equal to the 1/2. So pi 6 minus 1/2. So you add these two numbers together, and that gives you the final answer. Okay, you can do it. Add it together and simplify it. Simplify it yourself together. Okay, so this is a situation that you have. I think it's one of the problem maybe in your book. I don't remember, but it's popular just to remind you that you may have to use the integration by parts. So be ready for it. And you know that this method, we assume that you are familiar. If you are not, you know, we can use the integration, but it's a very easy method. It can be used. We are going to use it for the exponential function as well in the triple integral, and of course in the next example. Okay, any question? So that is 2b. I have to do the 2c as well, because the 2c you are going to getting in the same situation, and this would be a function. So add these two together and use your calculator to get the result. So let's see what it's about the 2c. Anytime you see in the trigonometric function and the exponential one in this double integral, you got to be careful. They are not difficult, but the possibility that you make a mistake are going to be quite a lot. Okay, so let's see what's going to be the 2c. 2c, you want to find this integral. Look at this. It's a double integral. These are very popular, you know, famous integral, really. I mean, if you do this review and these problems, you have all the possibilities, all the nice one. So then you are not going to be worried about. So just do it, keep it for your next test, and of course, final. Okay, so this is the one. You want to find the integral of double integral x by e to the y dA. The region is a rectangle again. So it's a square, in fact, 0, 1, 0, 1. So the situation is that, so over x is going to be between 0, 1, and the y is also between 0, 1. So now the integral is going to be, so we set up the integral first and then decide what are you going to do with it. So the limits are the same, 0, 1, 0, 1. The function is x, y, e to the y. Then you have to decide. You have the same problem like the other one that you did. You see, because you have the y and the y here. So if you want to do the y first, you have to do integration by parts. You can delay that one if you like for a while. If you want to delay it, you better go the x first. Okay, go the x first, then eventually you have to do integration by parts, but you can delay that one. So I go with the dx and the dy. Okay, any question? So get rid of the x first, then stay with the integration by parts. So that make it easy for us. So we do this part first. So it's like integral of the x, which is x squared over 2. So it's going to be 0 to 1. Okay, 0 to 1, x squared over 2. And the rest are going to be just y e to the y. Okay, and then of course x going from 0 to 1. Okay, and when you're done, you come back and you integrate respect to the y. Any question? So substitute when you put the one that give a 1/2 here. So you get a 1/2 of y e to the y minus, of course, 0 dy. So you end up with this integral. You can pull out the 1/2. So it's going to be 1/2 integral from 0 to 1, y e to the y dy. Again, you can integration by parts, tabular method. That table give you this result right away. Okay, this is the table. That is the sign. You integrate, you differentiate in this column. You integrate in this. So you put the y. Okay, y. Sorry, it's sign positive. Y is like u dv that you do in the usual fashion. Okay, and this is going to be e to the y. So you continue this column to get the 0 here. So we positive, negative for the sign, differentiate, you get 1, integrate e to the y, continue, sign positive, derivative of 1 is 0, integrate that, give you e to the y again. So cross multiply to get this. So your integral is going to be y e to the y dy is y e to the y minus, okay, minus e to the y, cross multiply. But it is from 0 to 1, 0 to 1, so we get 0 to 1. Any question? If you put the y equal to the 1, so that give you nothing. Okay, it's going to be e to the 1 minus e to the 1 minus, if you put the 0, that give you 0 minus e to the 0. Okay. So basically, this is it. These two would cancel out. This would be 1. So we get 1 here. But remember, there is a half here. So the integral would be 1/2. Okay, so the I, or the original integral, x y e to the y dA over the square is equal to the 1/2, the final answer. Any question? So just remind you, the techniques that we may have to do or to use to get these numbers. Okay, any question? So that's our first topic, if you like. Our first topic is we integrate, we take the double integral, but as you can see, we just do it on the rectangular region. These are all rectangle. So the next job is going to be if the regions are not going to be rectangle, curvilinear one. So the curvilinear one is the one that you have to set up the integral. Okay, then you may end up with 2 types of region. Remember the region type 1, type 2. So we give you one of these categories, and you have quite a lot over here to practice. So we go with the number 3. Any question? If you haven't seen this one, you better practice it because you need it for the double integral. We do it a couple of lot. When we get to the spherical coordinate, cylindrical coordinate, this is very popular. You will see it over there again. So you better check it. Okay, so we go to the number 3 on the non-rectangular region. Okay, so let's see what is number 3. So you want to find this double integral. I write it down so that we can describe the region. You want to find this double integral. Okay, this is the double integral x cosine of y dA. So what is the region? When R is bounded, when the region R is bounded or is enclosed by 2 function, 2 graph, bounded by the following. Bounded by, you have the y equal to the 0, which is the x-axis. Okay, y equal to the x squared, a parabola, and x equal to 2. Okay, so this is the region in question. So you have to set up this region to see what you have. Okay, what type of the region it is. Okay, so we have basically this parabola, and this is the x-axis, and you go with the x equal to 2, which is going to be a vertical line. So roughly get the graph of the situation. So this is it. So it's going to be a parabola curving up. Okay, this is going to be a parabola. This is, this is going to be your parabola here. So this is going to be y equal to the x squared, but where do you want it? This is y equal to the 0. Okay, but you want it with the up to the x to the x equal to 2. So if this is going to be 2, you know that you have to put it on this function, if you like, and that give you 4. Okay, you put x equal to 2 here, you know that y equal to the 2 squared, which is 4. So the region that we are going to have is between this parabola, the x-axis, and the vertical line x equal to 2. So this is going to be the region that you want to integrate. Okay, so this is the way you are going to allocate it. Now find the range for the x and the y. For the x, you go to the right to the left, and for the y, you go up and down. So easy one. This is type 1 because x goes to the right and the left, give you x between 0 and 2. And for the y, you can go up and down. You see up, down. If you go up, down, you are going to be always between the x-axis and between the x-axis, which is y equal to the 0, and the y equal to the x squared, which is your parabola. So your y is going to be from the bottom 0, from the top x squared. So this is a type 1 region. Okay, any question? So you have to have a good idea of the region because to get a proper limit of integration. Now we are ready to set it up. So this is it, the double integral x cosine of y dA. What we change into, as we talk about it, we have to do the y first, when we 0 to the x squared. Then we do the x. So the function is x cosine of the y. We do the y first. So this is going to be dy dx. So this is how you change it, or how you set up your integral. You have some problems in your book that they ask you to just set up the integral. Don't do it, but they are not going to give you this type of problems. Remember, always you have to do it. You have to find the result for us. Okay, now it's easy integral to find, of course, because we do the y first. We're just integrating the cosine, which is going to be equal to the sine, and then we continue and we get the result right away. Okay, so 0 to 2, integrate respect to the y, so that give you x sine of y. Okay, sine of y, but y going from 0 to x squared. And when we're done, we come back and we integrate with respect to the x. Okay, substitute for the y, so it's going to be 0 to 2 x sine of x squared minus x sine of 0. Okay, this is going to be the case, and then when we simplify it, you get the dx. Of course, sine of 0 is 0, so that would disappear. Okay, so you arrive at 0 to 2 x sine of x squared dx. Okay, u substitution give you this result right away. Okay, you know that if you take the u to be x squared, the du would be 2x dx. You see, you take the u to be x squared, so your du would be 2x dx. So you need a 2 here only. So if you want to do it in short form, this is the way we can write down as a 1/2 2x sine of x squared dx from 0 to 2. So I change it into the integral of sine u du, which is going to be negative cosine u. Okay, this is the way you can do it quickly, or you can go ahead and do all the operations, we don't mind. Any question? So I arrive at a -1/2 cosine of the u, which is a cosine of the x squared, but x going from 0 to 2. You substitute, you're done. So if you substitute -1/2 cosine of x squared 4 minus -1/2 cosine of 0. Cosine of 0 is equal to 1. Okay, negative would be positive, so the final answer is what? Is -1/2 cosine of 4. Okay, and what? That was +1/2. +1/2 is going to be the final answer. Okay, so it's very, very popular case. It's setting up this integral nicely. Don't try to memorize. Okay, some people, they say, oh, I have all these numbers, I know that. So, y is between 0 and x squared and the x, but it's better, to just get it, understand it. If the thing's getting complicated, then you know what's going on. But, it would be fine if you can set up the integral and we don't mind. Just, to start right away and do it for us. We don't mind to get the result. Okay, any question? So that's a kind of a straightforward one. We are very much interested, we give you one example, remember, we are very much interested in a triangular region. So you will see one of them, okay, so be careful. And you will see this triangular one, not only one, but also in future as well. So that would be the question number 4. Are you ready? 4. Again, experience, to be comfortable, and don't be afraid, when the problem would be given. This is the message of this. Okay, let's see triangular region, number 4. Number 4, you want to evaluate this, you see. You want to evaluate this integral, the double integral on of the y cube, and a dA is missing. It must be dA. Okay, over R region. What is the region? Region is going to be a triangle. So this is going to be where R is going to be the triangular region. Okay, it's going to be triangular with this, with these vertices. Okay, that's it, the vertices. There was a misprint somewhere. Let's see if it is correct. The vertices that's given to is 0, 1. Okay, this is going to be 0, 1. Then we have 7, 0. Yeah, the misprint is they give you 1, 1, which is not. Okay, so this must be 0, 0. With the 1, 1, you are not going to get a triangle. Okay, so this is the correct version of the problem. So double check on the given one is 0, 7, 7, 0 is 1, 1. It's not 0, 1, 7, 0, and the 0, 0. This is going to be the triangle in question. Okay, so you have to construct the triangle to see how you're going to handle you need the limit of integrations. So a solution, set up the triangle with this information that I gave you. Okay, so you have a 0, 1. This is a 1, 0, 1, 7, 0. Suppose this is 7. Okay, that's a 7, 0. Then the 0, 0. That's a 0, 0. Okay, so connect them together, they give you your triangle. So this is going to be the region. Okay, so this is going to be a triangle in question. Okay, this is going to be the case. Now this is our region that you want to integrate, and you have to decide what you're going to do with it, which type 1, type 2, to get the range of the x, you go to the right, to the left. If you go to the right, to the left, that gives you 0 to 7, which is nice. For the y, you go up and down. You see up, down, up, down, up, down. So up, down, the down would be y equal to the 0 here. And the up, you need the equation of this line. Okay, so your x is clear. The x is going to be, you see the x is between 0 and 7. That's fine. But your y is going to be between 0 and, okay, this is it. You have to decide what is this. So you need to equation of this line. You can find a different way to find, As you can see over here is rise, run. You can see that you get the rise of 1 and the run of the 7, and it's going down. So the slope of this line is -1, 7. And you already got the x-intercept, which is, y-intercept is 1. So -1, 7x plus 1 is the equation of the line. But sometimes you may not have it as nicely as is. So I just show you how we're going to find it, because there is one that you have to do this type of operations. So to find this y, you can imagine, one way to do it is just the slope. Okay, as I talk about the rise, run, and it's going down, y equal to the slope is -1, 7, x plus b. Remember the y-intercept 1. This is one way to find it. The other way to find it, if it's going to be not like this, nice, then you have to consider 2 points and find the slope. It's a long procedure, but it's not bad to know. So 2 points are going to be 7, 0 and the 0, 1, for example. You can find this slope. Okay, y2 minus y1, 1 minus 0. Okay, and 0 minus 7. So that giving -1, 7 as this slope. Then you can write the equation of the line, y minus y1 equal to the m times x minus x1. So it's going to be y minus y1, which is 0, and is a -7 times x minus x1, okay, which is 7. Okay, so that gives you y equal to -17x plus 7/7, which is 1. So we get the same answer, -17x plus 1. Okay, so make sure you know how to handle this problem. So you can go with the rise, run to get your slope and write it down. But if this triangle is going to be shifted up somewhere here, then you may have to use this type of ideas, okay, to get it. So be ready for it to find the equation of the line. You can find the equation of the line in 2 points are given to you. Okay, so now we are setting up our region. So the region would be x goes between 0 and 7, and y goes between 0 and -17x plus 1. Of course, this is type 1. Type 1 region. Any question? So this is one way to look into it. And now we know that bring the integral and set it up the integral with this information that you have, and patiently go for it. Okay, so that's the first part to design it. Okay, are you ready? So what was the integral? This is the integral, double integral of the y cubed dA, okay, over r. So now we know how to set it up. So it's going to be 0 to 7 for the x. Okay, and you get a 0 to -17x plus 1. And the function is y cubed. And you go with the y first. Okay, the y and the x. So this is your integral. Any question? So we have to do the y first. We have no other choice. So for the y, it's just the y cubed. So it's going to be y to the 4th. Okay. So the integral is going to be integral of 0 to 7. And that can be y to the 4th over 4, or a quarter of the y to the 4th. But then y goes from 0, which is good, but this is not good. -17x plus 1. Okay, and when we're done, then we have to come back and do it with respect to the x. Okay, you can pull out the quarter and then substitute this number. So it's going to be a quarter of the integral from 0 to 7. If you put the y in -17x, that gives you -17x plus 1, everything to the 4th. Minus if it would y equal to 0. If it would y equal to 0, that gives you 0. Okay, and then you are going to get the dx. Okay, so what you have to do, the next step is going to be a quarter integral from 0 to 7. Okay, 0 to 7 and negative 17x plus 1, everything to the fourth and the dx. You have to do your substitution to get it. Of course, you are not going to raise it to the fourth. If you do your substitution, and this is going to be, okay, you take the u to be this one. You can do the u substitution if you like, but I do it in the short form. I'm going to create the du, it's a negative 7x. So I need a negative 7 somewhere. Okay, so this is it. This is the way I do it. Okay, so this is it. So my du would be negative 17 dx. So I need a negative 17 to treat this one as u to the fourth. So what I do, I divide by negative 7 and multiply by negative 7 to take care of this one. Okay, so this is the way I'm going to create this. So it's going to be equal to, so I need a negative 17 inside. So what I do is I multiply the outside by negative 7. Then I divide this one by negative 7. Then I have the du. But you can do this substitution directly. It's the same thing. So as you can see, I have the du. Then this is simply is going to be u to the fourth. Integral of u to the fourth would be u to the fifth. So this is going to be negative 7/4 negative 17x plus 1, everything to the fifth, and then divided by 5. Then it's going to be evaluated from 0 to 7. Any question? So this is the way, I handle it to get it through. So I multiply this, the reciprocal of the 5 would be 1/5 times the negative 7/10 would be negative 7/20. Negative 7/20, then I substitute to get the final answer. Okay, so I'm going to squeeze it here. So it's equal to the negative 7/20. Negative 7/20 and negative 17x plus 1 to the fifth. Okay, going from 0 to 7. It's going to be equal to the, if you put the 7, this would cancel out. Okay, if you put the 7, this would be canceling out. You get the result. Okay, and if you put the 0, so that gives you just 1. So it's going to be like this one. So we get the negative 7/20. If you put the x equal to the 7, this would be canceled out. You get the 0 here, in fact. So that give you 0. Negative 17 and the 7, they cancel out. 0. And this is going to be negative 7/20. So if you put the y equal to x equal to the 0, that gives you just 1. So that gives you 1. So this would be canceling out. So the final answer is 7/20. And I just missed a negative sign here, make it a positive. So 7/20, if you believe it, that gives it the final answer. Okay, I just want to squeeze it here, then I didn't do the substitution. Okay, any question? If you put the 7, you see 7 and 7 would cancel out. That gives you negative 1 plus 1, which is 0. 0. Minus negative would be positive 7/20. If you put the x equal to the 0, the inside would be 1 only. So 7/20 is going to be the final answer. Okay, it's a very nice problem. Anytime you see the triangular one, you got to be careful. It takes times because you have to set up the triangle. Okay, going back to it and do it. And we are going to do this one a couple of more times. There is one case for the u substitution in a function of 2 variables. So you come back to it. So make sure you know how to handle triangular region. You will see it probably on your quiz and the test. Okay, so that's the idea for the number 4. Any question? Okay, so get practice, and there was a misprint with the 1, 1, you won't get anywhere. It must be 0, 0. So that is a triangular region. Let's see what's going to be number 5. And number 5, not bad. The volume problem is very popular problem. Remember, the double integral can take care of the volume for us. Of course, the triple integral would do the same. This is a very standard situation they're going to have. So application of the double integral for the volume. Number 5. So it's a volume problem. So you want to find the volume of a, okay, two-dimensional solid. So this is it. I just give you, because I need to explain the region. So find the volume. Okay, find the volume of the solid, three-dimensional solid. The information is that lies under, you know, that the three-dimensional solid that you're going to have is going to be from the top bounded by the surface of the given function. From the bottom in two-dimensional is going to be usually a rectangle for this one. So we want to find the volume of the solid that lies under. Okay, under hyperboloid or hyperbolic. That's it. This is hyperbolic. Is a hyperbolic paraboloid. Paraboloid with this equation. Equation is z equal to the 4 plus x squared minus y squared, and the region, the down and above the square. Okay, above the square r, which is going to be negative 1, 1 cross negative 1, 1. Okay, you can use a graphing calculator. Oh, sorry. It's a negative 1, 1 and the 0, 2. It's going to be a rectangle. 0, 2. Oh, is a square. Negative 1, 1. The difference is 2 units. Okay, it's a negative 1, 1 and the 0, 2. Okay, negative 1, 1. And this is 0 and 2. It's a square. Okay, you can see it by those graphing that we showed you the other day. Okay, so it's a volume problem. We talk about it. The volume problem can be done by the double integral. The double integral, the differential is d of a, which is the area. You can consider the function f as a z or just the height. So you have the height times the area, pick it to the volume. So basically, this is how we are going to set up the problem. Okay, we say that, the volume is, this is it. The volume is just a double integral. So the double integral on R, the function fx, y, dA. That's the interpretation of the double integral as a volume. Now, the region that you're going to have, f of x, y is just the z that you have over here. Okay, so your f of x, y is just a given z, which is 4 plus x squared minus y squared. Okay, and then the region in two-dimensional, the projection, this is a square. You know that this means your x is between negative 1 and 1, and your y is going to be between 0 and 2. Okay, so these are the information that you have. So, you know, that will cover the function, and the region is going to be just a rectangular region. So this is it. The volume is going to be, that's it. The double integral is, the function is 4 plus x squared minus y squared. And you just decide which one goes first. It doesn't matter really because it's a rectangular, and you know, it doesn't matter which one goes first. So the way I did it, I just go with the y first. So I go with the 0 to 2, then I do the x, -1 bar. It's a polynomial and everything else, you can reverse the order easily and nobody would, would be harmed if you like. Okay, any question? So this is the way we are going to set up the volume. So we are going to do the first part first. We integrate with respect to the y. So integrate with respect to the y, so it's going to be integral from -1 to 1 respect to the y. So that give you 4y, that give you x squared y, and this is going to be y cubed over 3. Okay, this is it. And now you have to evaluate it. So you evaluate everything here from 0 to 2. And when you're done, you come back, you integrate with respect to the x. Okay, carefully substitute for the y, 2 and 0. So if you put the 2, this is it. It's going to be -1 to 1. So it's going 4 times 2 plus 2x squared minus 2 cubed over 3. If you put the 0, everything would be 0. Then the dx, okay. So it is going to be equal to the -1 to 1. So that gives you 8 plus 2x squared, and this is going to be 8/3 dx. Okay, so integral from -1 to 1. 3 times 8, 24, 24 minus 8, 16. So we get the 16/3 plus 2x squared dx. So easy function to integrate with respect to the x. So it's going to be 16/3 x. 16/3 x plus 2x cubed over 3 to be evaluated from -1 to 1. Any question? You substitute, it's a hot function, you substitute just one of them, or you can do it to get the result. So if you put the 1, that give you 16/3 plus 2/3. If you put the -1, would do the same thing. You see, it's going to be -16/3, and this would be -2/3. Because, -1 cubed would be just +1. So it's the same number. So it's a 16/3, 2/3, again a 16/3, and the 2/3. Add them together, 16, 16, 32, and 36. 36 over 3, which is 12. Okay, 12. So the volume in question is going to be 12, whichever unit it is, cubed. Okay, so the volume is equal to 12. Okay, so that gives you the idea of interpretation of the double integral as a volume. So we are going to check one of these. Any question? So that's our second concept, if you like. It's just like the setting up the integral, the double integral, but they are the same category. But we would like you to make sure that you understand, that the volume can be done by the double integral. In future, we can do it with the triple as well. If you want to do it with the triple, you see the way you write it down. We talked about it the other day, but we are not going to do it now. You get the triple integral, but this would be z from 0 to this. But the double integral is much, much easier. Of course, you don't have the triple integral, so you have to use this method only. Okay, that's number 5. Any question? Now, number 6, a great problem here. Remember, there are some integral that it's not easy to find. So what we can do, we can use the reverse of the order to be able to integrate it, okay? So that's the idea of number 6. Okay, we are going to give you a hint of integrating by reversing the order. Some very famous integral, okay? So this is number 6. All the VIPs are here, all the possible one. So you can't miss it. This is number 6. Great application of this. So we give you the hint, evaluate. Okay, evaluate the integral by reversing Okay, reversing the order of integrations. Okay, so we call it reversing the order integrations. That's the idea. Okay, it's easy problem, but you can easily miss it. So be careful when you're changing, those region. So a famous one, we talk about it, e to the x squared, the first one, sine x squared, cosine x squared, sine x over x, and just the ln function. Okay, so almost all the same. So I call the first one part one. We did one version of this one the other way, 0 to 1, normal distribution type. 4y to 4, and the function is e to the x squared, dx dy. See, that's the first one we want to check. And so as you can see, the difficulty is if you want to stay with as given, you have to integrate respect to the x, which is not possible because this is e to the x squared. You need u prime. U prime would be 2x, which is missing. So it's not possible to do it with x. So we have to switch the order, do the y first. Since they are not numbers, so you cannot do it just right away. You have to check it because they are functions. Okay, so that's why. So you check to see what you have and you change it. So this is the way you are going to operate for this one. You check the information. The information that you have is that the y is between 0 and 1. And the x is between 4y. You see 4y and 4. That's it. So you check to see what equation you have. So you get x equal to the 4y. And then since you need to change it, so you find the y would be a quarter of x. Okay, so this is the relationship that you have. So if you graph this part, the region that you have, or the region that you integrate is this one. Okay, and so this is the line passing through the origin. So this is going to be the 0. And you know that this is going to be your line. But you want it between 0 and 1. If you put the y equal to 1, x would be 4. So that's going to be 1, 2, 3, 4. So that's going to be the 4. And y equal to 1. So this is 1. Okay, this is 4 and 1. So the line is this one. Okay. So that's a line y equal to the, whichever, x equal to the 4y or y equal to the, okay, this is going to be your line, y equal to the quarter of x. So this is 0 and this is 1. So the given one is this one. Okay, so what you have here, so you have that the y is between 0 and 1, so they go up and down if you like. And then this is it. So y, they fix the y between 0 and 1, so they go to the right to the left in this case. You see the right to the left are going to be the one that is given to you. X between the x equal to the 4, which is a vertical line, and this is going to be just your graph. So the way they did it, it's a type 2 region. Okay, it's a type 2. So what you want to do, you want to switch this. Switch from the horizontal one to the vertical one. So if you get this graph again, these are just for your information. So if you get the graph, the same graph that we have, so that's a 1, that's a 4, and that's a 0. And this is the line that we have. So what we would like to do is we'd like to fix the x this time. So we fix the x between 0 and 4. This is going to be the x. Now we are going to go up and down to get the y. So to get the y, you see the x-axis, the line. This is going to be the y. So your y is going to be between y equal to the 0, which is the x-axis, and this line, which is y equal to 1/4 of x. So your y is between 0 and 1/4 of x. Now we can switch to integral. Okay, and these are going to be limit of integrations. Any question? So it's just switching, you just find out which was the starting point. Okay, then accordingly you switch it. So now we know that the given double integral is 0 to 1, 4y to 4, okay, e to the x squared dx dy. So the new case is going to be switching. So you do the x at the end, so it's going to be 0 to 4, and your y is going to be between 0 and 1/4 of x. Okay, the function is going to be unchanged, but you do the dy first and the dx. Any question? So that make it very easy, because if you do y first, this is just a number. So it's going to be a y e to the x squared. Then you bring this one down, that give you the u prime, and you'll be able to do it right away. Okay, so we do this integral first. So that gives us integral from 0 to 4, but that would be y e to the x squared, and the y going from 0 to 1/4 of x. Okay, and when you're done, you take the dx here. Okay, substitute, so it's going to be 0 to 4. So if substitute, that give you 1/4 of x e to the x squared minus, if you put the y equal to 0, that gives you 0. Okay, 0 dx. So you have 0 to 4, 1/4 of x e to the x squared. Nice. You see, you create your prime here. So you can pull out the quarter, 0 to 4, x e to the x squared dx. You see, if you take the u to be, if you take the u to be x squared, your du would be 2x dx. So I needed 2 here. So this is the way I do it. I multiply by 2. Okay. Integral from 0 to 4. Sorry, I divide by 2. Sorry. I divide by 2. And then multiply by 2. See, that's it. But I put this one inside. 2x e to the x squared dx. It's the same thing. So I have the du. Okay, so I create the u prime. So this means this is going to be equal to the 1/8 e to the x squared. You can do the u substitution in full details if you like. But going from 0 to 4. So if you substitute, that give 1/8 e to the x equal to 4, I can do the 16 minus 1/8 e to the 0. E to the 0 is 1. So that give you 1/8 e to the 16 minus 1/8. That's the final answer. Okay, some people like to factor out the 1/8, but that's optional. Okay, so that give you e to the 16 minus 1, the final answer. Okay, very nice techniques, but you should be careful to be able to set up this. Okay, you have to explain it for us, how to do that. I mean, if you know that you're just starting from here, we accept it. Okay, but graph it's tricky to make sure that you know what method it use and what you are going to do to change it. Okay, to get this one through. So let's do one more, then I give you a break, because there are all are one that takes time. I want to make sure you'll be able to do it. So I do one more for you. This next one, we didn't do it. It's a kind of first step integral. It's one of those integral that's impossible to find. Sometimes some people, they ask you to do it in calculus 1, calculus 2. It can be done by as a single integral, of course. It can be done by the complex numbers or complex variable. So this is part B. The part B, you want to find this famous integral 0 to 1. Okay, x to 1 sine y over y dy dx. You see, as is, you can't do it. Can't find the integral of sine x over x dx in calculus. I mean, with these methods. So what we like to do, we want to switch it. If you switch it, that would be a constant. Then you'll be able to do it right away. But we have to check to see what method, what region is this one, and how we're going to switch it. Okay, again, look at the region to see what's going on, solution. So what we have here, they go with the x is between 0 and 1, and the y is between x and 1. Okay, so you let this one to be equal to each other, y would be equal to the x, which is very easy because you don't have to change it. So let's see what region it was or it is so that we can change it. This is it. The line is y equal to the x, but you want it between 0 and 1, so it's going to be 0. If you put x equal to 1, y would be 1. So this is going to be the line passing through. Okay. So this is the line y equal to the x or x equal to y. So the way it is suggested, they fix the x, you see, between 0 and 1. And then they got the y. So for the y, they just got this one up and down, you see. Oh no, this is tricky. So what is the region? You see, the way they did it is y greater than, you are here. Y is greater than x and less than 1. Okay, so the region in question is this. You see, that's going to be the region. And this is going to be the region. Because they fixed the x between 0 and 1. This is between 0 and 1. And for the y, you're just going up and down. So the up and down is going to be between these two lines. Okay, it's not 0, it's 1. Okay, now switch. Same region, but instead of going up and down, you are going to go to the right, to the left. So if we switch, it's the same thing. You can, check it over there too. It is going to be the same thing. So this is going to be the 0, and this is going to be 1, 1. And the line is going to be the same line. Y equal to the x or x equal to the y, both of them are the same. So what you would like to do, you'd like to do the other way around. So the other way around is you'd like to fix the y. So you fix the y between 0 and 1. So that's going to be y between 0 and 1. Then in order to get the x, you go to the right, to the left. You see right, left, right, left, right, left, right, left. So your x is going to be between the y-axis, which is x equal to 0, and this line over here. So your x is going to be, okay, so your x is going to be between 0, 0 to the left, and the y to the right. So that's going to be the case. Any question? So you have, you better graph it to see exactly, especially this is tricky that, you get this 0 here, but you get a 1 here. Otherwise, your result, if your result integral is going to be not something not doable, if you like, you probably miss one of these, this end point of those limit of integration. Okay, question? So that's it. Reverse it, change it to this, and then do that. So the original integral was 0 to 1, x to 1, sine y over y, dy dx is equal to, so we switch. So we have to go last with the y, and then this is 0y. Now that's a sine y over y. We go with the dx first and then the dy. Okay. Any question? You see? Now this is easy to handle. Because sine y over y would be considered as a number. So we're just integrating dx, which is x. So this is going to be equal to integral from 0 to 1. Okay, 0 to 1, it's going to be sine y, now x, okay, x times x, but x going from 0 to y. Then when you're done, you come back, you integrate respect to the y. Okay, replace x by 0. If you get 0, you get 0 here. If you put the y first, of course. It's going to be sine y over y. Now y minus 0 dy. You see the y and y would cancel out. This is where you get you get your result. So you integrate in simply 0 to 1 sine y dy. You know the integral of a sine is what? Is a negative cosine y, and you're going from 0 to 1. So it's going to be negative cosine y minus cosine of the 0. Cosine of the 0 is 1. Okay, so it's going to be 1. So the final answer, negative cosine y plus 1. This would be the final answer. Very nice and nice example of this type. Okay, any question? So again, experience, okay, seeing it, then we're able to set it up nicely. Okay, it's 12, give you 10, 15 minutes as a break. We come back and I have to do the integration. The polar form one are the main one that we have to do, and a couple of problems on the surface area to be able to do it. Okay, see you then. Okay, we are going to continue. There is one regarding the ln function. I do that one too. It's for C. Just make sure you have there's a point about this one that make it different. Okay, so again, reversing the order to find this integral. So that's C. So the integral is this one. So 0 to ln 10. Just double check, make sure you get that one. Must be the same one. Okay, integral from 0 to, yes, that's it. 0 to ln 10, then e to the x to the 10 again. But the function that we have is 1 over ln y. ln y, now this is a dy dx. You see again, this integral as is not possible to find because you can't do anything to this ln of the y here. Even if you move it up, then you need u prime to be able to handle it. So it's not possible. But if we can switch it into the x, this would be a constant. Then we can take care of the x, and then e to the x would be helpful. So we have to look at it to see what type of the region is this, and then when you want to reverse it, the reverse order, get the information. Okay, so this is it. As is, they go with the, you see this is your x is going to be between, your x is between 0 and ln of 10. Don't try to change it to the decimal number, keep it as is. Okay, this is going to be the case. And the other part is going to be, you have the y. So your y is between e to the x and the 10. So this is the way you are going to look into it. So we check this one first. It's going to be y equal to the e to the x. Okay, so this is going to be y equal to e to the x. Then if you want to switch it, you should be able to find the x. You know that if you want to find the x, the inverse of this is the ln function, or you can take the ln of both sides to get it. You see, if you take the ln of y, this is going to be ln of e to the x, but ln of e to the x is just x. So if you switch from y to the e to the x, then you switch to the x equal to the, okay, x equal to the ln y. So that's one point about this problem. And the other part, of course, is y equal to the 10. So if you get a graph of this region or this part to see what is going on, that's going to be the case. So, you know, you can consider the function to be exponential one. This is it. You know that exponential function, when e equal to the 0, that give you 1. So this is going to be the function, okay? This is the function y equal to the e to the x. Okay, e to the x, when x is equal to the 0, so that give you 1 here. Okay, so this is going to be the case. Then the end is, then you have y equal to the 10. So y equal to the 10 is going to be just straight line. So suppose this is going to be y equal to the 10. So you get this graph, a straight line. So that gives you y equal to the 10. Okay, so as you can see, this is it. The y equal to the 10, and this is going to be your exponential function. Then your x is going to be between 0 and when you put the x equal to the 0, that give you 1. So you're going to be here. This is going to be 1 point. And then x equal to the ln 10. So that's it. If you you see, x equal to the ln 10 is going to be here. Okay, y equal to the 10. You see, it's like y equal to the 10, x would be ln 10. So this is going to be ln of 10. Okay, so now where is the region? The region that you're going to be interested in is going to be x between 0 x between 0 and ln 10. So it's going to be a type 1 region if you like. So, and in order to get the y, they go up and down to find the y. So if you go up and down, you see this is it. The up would be y equal to the 10, and the down would be y equal to the e to the x. So originally, this is the way you look into this region. Okay, now what you want to do is you want to change it, reverse the order. So you want to reverse the order, you're going from this side. So when you switch it, we can do it as is. I just want to explain it more for you. So if you switch it, this is a situation that you're going to have. It's going to be the same graph. Okay, this is going to be your same graph, and this is going to be the line that you have. You see, that was the line y equal to the 10. So this is 10. Okay, and this part over here is 1. So what you would like to do is you would like to, in this case, you fix the x. So you want to fix the y over here. So we go up and down. So y would be between 1 and 10. Okay, and they pick the up and down over here. You do it the other way around. So we're going to pick this distance here. See, for the x, going to the right, to the left, to the right, to the left. If you go to the right, to the left, you see to your right is going to be just the y-axis. So your x is equal to the 0. And to your left is just this is it. To your left is just your x equal to the what? X equal to the ln y. So this is going to be ln y. So this is the way you are going to switch it from this is the type 1 region. So that's a type 1 region. Okay, type 1. And then you switch it into the type 2. Okay, so we change the limit of integration, y between 1 and 10, and x between 0 and ln y. Any question? Now we can easily integrate it. If you switch it, you see the integral is going to be very easy to find. I'm going to put it over here for you. Okay, so there you are. Originally, you did have the 0 to ln 10. Okay, e to the x to the 10 and 1 over ln y dy dx. Now we switch. That's it. Now we switch into this one. Y is going to be fixed, so y is going to be outside 1 to 10. So the x would be inside between 0 and ln y, and everything else would be unchanged. It's going to be 1 over ln y. Okay. Now we switch the order, make it to the dx, then the dy. Any question? Now, as you can see, this is considered to be a constant. So integral of a dx would be just x. So you end up with a 0 to 10. This is going to be 1 over ln of y times x. Okay, times x, but x going from 0 to ln y. And then when you're done, you are going to integrate with respect to the y. Okay, now you substitute. So it's going to be 0 to 10. 0 to 10, 1 over ln y. Replace the x by ln y. Okay, minus when you replace it by 0, that gives you 0. So as you can see, ln 1 and ln 1 and then y would be cancelled out. So we get 0 to 10 dy, which is just y, from 0 to 10, which is equal to the, okay, it's a 1 to 10, sorry, 1 to 10, 1, 1, 1. So it's going to be 1 to 10, which is going to be 10 minus 1. The result is 9. So the result of the integral is 9, and nicely done. It's very, very nice example. But you have to switch it carefully for the case of the ln function. So this one, the other one is when you consider the inverse function, because it's the inverse function. You have to know that the inverse of this exponential function is the ln function, or the inverse of the ln function is going to be exponential function. Okay, so this is going to be the case. The part D of this one is easy. I do the D so that we have the complete solution of this number because of the very important procedure. And nice, really. Okay, are you ready? I think I did this one. Yes, I did the part D during the lecture. That's the first net integral. Okay, so the part D is the one that we did, I think. So this is 0 to 1, x to 1, sine of y squared. Okay, dy dx. I think I did this one. Just check. Otherwise, I write the solution for you. So reversing the order. Yes, I did this one the other day. So just check this one. 0 to 1. You just switch the variable. So check this one for yourself. Okay, so see your lecture notes if you like. Because when it's posted, you know. So we did all these cases for the for the reversing the order. It's very important, you know, important procedure. So this is number 6. Number 7 is easy problem. Okay, I can quickly give you the idea. This is similar to the one that we did again, the volume problem. Okay, so number 7, I will set it up. It's a volume problem. You want to find the volume of a kind of a tetrahedron bond. Find the volume. Okay, volume of the solid. Under the plane. Okay, the plane is given to the plane is x plus 2y minus z equal to 0. Okay, that's a surface and bounded above and above the region. Above the region, that's going to be bounded by region bounded. Okay, bounded by y equal to the x and x equal to the y equal to the x to the 4. Okay, it's just like a double integral type. We can set up this one for you and just give you, just if I can give you the result of this. Okay, so it's not difficult to set up. I just want to see if I have the numbers. I can be quick to take care of this. That's a number 7, 6. Okay, I set it up somewhere and then you can continue. So this is it, and not difficult. It's a volume problem. You need a function. Okay, so this is going to be the solution. So remember, the volume is what? The volume is simply the double integral on R. So the function is f of x, y, and this is going to be the dA. The function is question, you have to solve for z to get your function. Okay, so you have the x plus 2y minus z equal to the 0. So you solve for z, z would be, okay, x plus 2y. This is going to be your z, and your region is going to be the region between, you know, your y going between, okay, between the x and the, okay, and the y is going to be between x and x to the 4th. So we can easily check this one. You know, even you can graph it if you like, but you need the okay. So you need to intersect y equal to the x and y equal to the x to the 4 to be able to find the limit of integrations for that part. Okay, and then you'll be fine. Okay, so this is going to be the result. So we have to intersect this one because we get the z. So you have because the region is going to be between the line here and the curve. Okay, so put them together, y equal to the x and y equal to the x to the 4th. To get the limit of integration, it's going to be x to the 4th equal to the x. Okay, you move it to one side. So that give you, we can handle it by taking out, solving it. Put out the x, that give you x cubed minus 1 equal to the 0. So that give you x equal to the 0, 1 solution, no complex numbers, remember. We're dealing with the real things. So it's going to be x cubed equal to 1. So the other solution would be just 1. Okay, so your x is going to be between 0 and 1. Okay, this is going to be your x. So basically, roughly, if you like, this is the region that you're going to integrate. The line y equal to the x, this is going to be y equal to the x. Okay, from the 0, and you can consider this one to be 1. So this is it, 0, 1. And that y equal to the x to the 4th, that you're going to have it, is going to be something like this, you see. So this is roughly is going to be the region that you are going to be concerned with. Okay, that's it. So your x is going to be between 0 and 1, and your y is going to be up and down. So y is going to be between, okay, I think it's between x and x to the 4th, or x to the 4th is down here. Okay, it's going to be between x to the 4th and between x. Remember, x is between 0 and 1. Any number between 0 and 1, if you raise it to the 4th, the number would be smaller. So that's why it's going to be the bottom one is x to the 4th. Okay, now we are ready to get the result. So this is it. The volume is going to be a double integral. X is between 0 and 1. Y is between x to the 4th and x. And the function. The function is x plus 2y. And you're integrating respect to the y and then respecting to the x. Okay, easy integral to find to get this. Okay, this volume done. Okay, any question? Integrate respect to the y quickly, and you substitute to get your result. So it's going to be 0 to 1. Integrate respect to the y is going to be xy plus 2y squared over 2, which is going to be y squared, and evaluate it from x to the 4th to the x, then the dx. You substitute the y equal to 4, everything would be in terms of the x. We can do it right away. Okay, so this is going to be 0 to 1. If you substitute the x, so that gives you x squared plus x squared, minus if you substitute x to the 4th, so that gives you x to the 5th. Okay, x to the 5th plus x to the 8th. See, you substitute here, so everything dx. So this is going to be 0 to 1. Okay, 0 to 1, 2x squared minus x to the 5th minus x to the 8th and the dx. Okay, easy integral to find. You just integrate it and you substitute to get the numbers. Okay, so I just quickly give you the results here. So that gives you 2x cubed over 3. Okay, minus x to the 6 over 6 and minus x to the 9 over 9 from 0 to 1. Leave it for you to find it. Okay. So you should arrive at 7 over 18. 7/18 is the final answer. So the volume is going to be 7 over 18. Okay. So that will take care of the number 7. Any question? And number 8, again, is a triangular one like the one that we did. I set up the triangle and then I leave it for you to finish it. Okay. So going back to the number 8. It's, I need to have that triangle. Okay, number 8, it's another triangular case. I told you triangular case, very popular one, you must know it. So number 8, finding the volume of the solid again. Find the volume, okay, of the solid. Volume of the solid under the surface. Okay, so under the surface, the graph of this function, the function is equal to the xy and in 2-dimensional and above, okay, above a triangle again, above the triangle. Okay, above a triangle bounded by the following vertices, okay, with vertices. So these are the vertices of a triangle. This is a little bit more involved than the other one that we did because of the shape of this point or the position of this point. 1, 1, 4, 1, and the 1, 2. Okay, that's 1. The only part is in 2-dimensional and the situation of a triangle. Otherwise, it's nothing to worry about. Okay, so you have to set up the problem. So from the volume point of view, this is it. So your function is z equal to the xy, and you have a triangle with the following vertices that we talk about it. And the volume is going to be just a double integral of the function, okay, over this region. The function is just xy. So you have to find this integral simply on a triangle. So you have to construct a triangle to find out the limit of integration for the x and the y as we did for the other one. So I just quickly do it partly and then you finish it yourself. So get the triangle. It's going to be more involved because of the position of a triangle. So 1, 1, this is going to be, suppose this is 1, 1. So this is one vertex, 4, 1, 2, 3, 4. So that's a 1. This is 4. This is another point of a vertex. Then 1, 2, 1, 2. And this is going to be the third one. So if you connect them together, you see, this is going to be your triangle. So as you can see, your x is going to be between 1 and 4, as we did it for the other one. So x is going to be between 1 and 4. Then you have to decide what are you going to do with the y. So for the y, you go up and down. You see up, down, up, down. So down is clear. This is a 1. So it's going to be bigger than 1. But you have to find the up. The up is going to be the equation of this line. Equation of this line. Again, you know, we can go with the slope if you like. And the rise run is, this is 1 and this is 3. 1, 3, the slope is negative 1/3. And then you don't have to intercept, you have to find the other points. But you can do it as I talk about it, just, you can pick these points if you like. The equation of the coordinate of this point is going to be 1 and 2. And the coordinate of this point is just 4 and 1. Just, it can be done quickly, but you can go with the general method of finding the equation of the line if you are not sure about it. So you have 2 points. You can find the slope. We already talked about the slope. Y2 minus y1, 1 minus 2, 4 minus 1. So that gives you a negative 1/3. Then you write the equation of the line, y minus y1, y minus 2 equal to the m, negative 1/3 times x minus x1. Okay, you move it to the other side and simplify it, negative 1/3 x plus 1/3. You add the 2, so y would be negative 1/3 x. Negative 1/3 x plus 1/3 plus 2, 6, 7, 7/3. So y would be negative 1/3 x plus 7/3. Okay, so this is it. That's the equation of this line here. So your y now is going to be between 1, you see, y is between 1 and this line. And your x is going to be between 1 and 4. So this is where you are going to integrate. Okay, so you put these numbers here and you integrate to get the okay, to get the final answer. So I will set it up and I give you the, let's see if I have the final answer. It's not difficult to find, but it takes times. Okay, so let's see how far we can go to get it. So I don't have the final answer, so I just set it up and ask you to continue, because these are going to be messy to know to do it, but it can be done. So let's set it up. So what you are going to do is, this is it. That's the volume. Double integral over R. So it's going to be, this is it, over R. Now you know the R is going to be double integral. Okay, x is 1 to 4. Y is 1 to negative 1/3 x plus 7/3. Okay, x times y. So it's going to be simply dy dx. That's it. It's easy integral because that's going to be y squared over 2. Just substitute using the FOIL method to do it. Okay, so I do one part, it's going to be 1 to 4. If you do this this integral respect to the y, so that gives you x y squared over 2, but your y going from 1 to negative 1/3 x plus 7/3. Okay, and when you're done, you just do the dx. This is going to be the one. I leave it for you to do it. Okay. The other one that I did was the limit was easier, but this is not bad, and eventually you'll be able to find it. Okay, so the triangular one, I told you, triangular one is the one that you have to be careful about. Okay, so you have to rush to get to the polar form. So that gives you enough examples really on the volume problem. There is one more. This is the one that I did. It's the tetrahedron. Okay, I just remind you because there is a misprint on this one, but otherwise this is the one that we did the other day. Okay, any questions? So make sure you know one triangular integrated on the triangular version that I did. So this next one, finding the volume of a tetrahedron. I did it exactly the other day. So number 9, okay, you would like to find the volume. Let me just bring it back. The volume of the tetrahedron. I just don't want to shave those, so I have to go back and, because otherwise I will lose that second camera. And so this is with the misprint, finding the volume of a tetrahedron. This is find the volume. There's a misprint here. Find the volume is a tetrahedron of the solid under the plane, under the plane. You see the plane that's given to you is x plus y plus z equal to the 0. You can't do it with 0. It must be 1, any number. 1 would be fine. Okay, and above the, above, okay, and above the region bounded, above the region bounded by coordinate planes. Okay, by the coordinate planes. That's exactly what we did the other day. It's very easy to set up because you have to find the z. You see, this is the one that I did. I set it up again. Then you can check it for yourself. We go to the double integral. This is one of the methods that, where is the tetrahedron that I did for the volume? I will set it up, then you can check it. It's very similar to this one. You see, that's the one that we did. Volume of a tetrahedron. This is in this version, but I set it up and then you finish it. It's a very popular problem. Okay, so this is it. The solution is going to be, the formula for the volume. Again, the volume into the, for the double integral, the function dA over R. So your function is, you have to solve for z, x plus y plus z equal to 1. So z would be 1 minus x minus y. This is going to be your function. Okay, so your function is 1 minus x minus y. This is the function. Then this is going to be above the region bounded by the coordinate planes. So what you have to do is, remember, you are going to project this one into 2-dimensional. You replace the z by 0, you drop it down into the 2-dimensional. So that gives you x plus y equal to the 1. Remember exactly what we did. You replace the x by 0. That gives you y equal to the 1. Replace the y by 0. That gives you x equal to 1. And this line is, that's it. You get the x and the y intercept. It's going to be 1 and 1. So you connect them together. That is the region, triangular. So from right to right, x is between 0 and 1. And the y, you solve for y here. So we get a y equal to the 1 minus x. So y is between 0 and 1 minus x. So simply you integrate this one and you get the final answer. Okay, check your lecture notes and you will see it. So the v is going to be double integral. The function is 1 minus x minus y. You integrate in respect to the y, then respect to the x, y going from 0 to 1 minus x, and x going from 0 to 1. So, easily integrable. It's the same as the one that we did. Okay, so integrate it and find the y. Okay, so that was a misprint. It's not 0. You can't do the 0 one. So that gives you the one that we did. Okay, any questions? So that will give us time to go to the polar coordinate and make sure that we are able to do the polar coordinate, just at least a couple of them. Okay, so that would be, so these are all the same really, just get the idea and you'll be fine. That's 9, 10. Polar coordinates. We are going to give the instruction. We ask you to integrate using the polar coordinate, so you have not difficulty to get the result. And we talk about how we're going to do it. The coordinates x and the y. You go to the polar coordinate. X would be r cosine of the theta, y r sine of the theta, and you switch it. Okay, so this is number 10. Double integral in polar form. Okay, double integral in polar form or polar coordinate. Remember the way we're going to do it, you switch your integral into the polar form. And the way we do it, whatever it is, we change it into the double integral. Your function is going to be f of, replace x by r cosine of the theta, replace y by r sine of the theta. There is going to be Jacobian, an extra term when you change variable. That extra term is r dr d theta. R going from, it's going to be mostly number, but sometimes it may be a function. So we call it, R1, R2, if you like. Okay, I call it R1, R2. And this is going to be theta 1, theta 2. But this can be a function of theta. Okay. So very standard one, circle, semicircle, a quarter of a circle are the situation we're going to have. This part 1 is a very similar one that we did the other day, so but I explain it quickly again. So the part 1 is this integral, 0 to 2, 0 to radical 4 minus x squared, and the function is square root of y squared, x squared plus y squared, dy dx. That's it. You check to see what region do you have. You change it to the polar coordinates, identify the range for the r, which is the radius, and the data, and make sure that you have this extra number here, okay? So what do we have? You see here, this is x, so your x is between 0 and 2. Your y is between 0 and a square root of 4 minus x squared. We're going to work on this one. You let it to be equal to, and that's a semicircle. Okay, even you can square it if you don't believe it. So that gives you y squared plus x squared equal to the 4. So you are going to have a semicircle. You have a circle or semicircle because y is positive. So circle with the radius of 2. So that's going to be 2. And this is going to be negative 2. And this is also 2. So this is going to be what information that you are going to get from the y. Question, because y is positive, so upper part. Now check x. You see, ordinary one, x is between negative 2 and 2. But over here, x is between 0 and 2. Since it's 0, 2, so you are going to be concerning only with a quarter of a circle. That's it. R is the radius of this circle. It's always R between 0 and 2. But your data, since you are in a first quadrant only, is going to be between 0 and pi half. That's it. So you change this integral into the polar by replacing the x and the y by this. x squared plus y squared would be r squared. So your integral is going to be the following. We call it I in polar form. Your r is between 0 and 2. Your data is between 0 and pi half. Your function as a radical x squared plus y squared is r squared. So that gives you r squared. Extra 1r dr d data. This is the way we do it. Any question? If it is not going to be popular, we substitute. But this is popular. X squared plus y squared is r squared. So this would be r. R times r would be r squared. So it's going to be 0 to pi half, 0 to 2, r squared dr d data. Any question? Integrate respect to the r. The integral are very easy for the polar form. Okay, so that gives you 0 to pi half. And that gives you r cubed over 3, r going from 0 to 2. Then you come back, integrate respect to the data. Replace r by 2, that gives you 8/3. R by 0, nothing. So 0 to pi half. 8/3 of the d data is going to be 8/3 times data going from 0 to pi half. So it's going to be 8/3 times the pi half. So 2 and the 8 would be simplified. 4 pi/3 is the final answer. So the integral would be equal to the 4 pi/3. Okay, so it's very easy a procedure when we change it to the polar form. Any question? So make sure that the limit of integration is consistent with the region. Okay, so you may be given semicircle, full circle. So to compare it, that was part 1. Any question? Let's see what's special about part 2. They changed it a little bit, but it is the same problem. Are you done? So when it's a circle, you have nothing to worry about. It can be done, and we are going to use it after your test. We go to the spherical coordinate, and we use these type of ideas in 3-dimensional. Okay, let's see what's special about B. What's B? We want to find this integral using polar form. -2 to 2. Next, negative square root of 4 minus y squared. Square root of 4 minus y squared. Function e to the negative x squared plus y squared, you see, dx dy. You see, these expressions are all over the places. You can't do it if you don't want to use the polar coordinate. With the rectangular coordinate, it's not possible. Are you ready? Check to see which region do you have. You see, y is between -2 and 2. That's y. Then what you have, your x is between these. X is between 4 minus y squared less than x less than 4 minus y squared. You have to work on this one. Equality, x equal to, so x is equal to positive negative 4 minus y squared. You see, it's a full circle because of the positive negative. So you square it and you arrive at x squared plus y squared equal to 4. So that gives you full circle, the top and the bottom. So this is your region. Your radius is 2. Okay, so the radius is going to be 2. We get a 2, -2. Okay. This is a situation you're going to have the top and the bottom. Okay, the top and the bottom, and y is between -2 and 2. You see, this is 2, this is -2. So as you can see, you're using all the point of the circle in this, okay, for this problem. Okay, so this means you're using the full circle. Okay, so your r is the radius of a circle, which is between 0 and 2. And the data, since you're using the full circle, so the data is going to be between 0 and 2 pi. That's it. So that gives you the indication. You say positive, negative over here, and then -2 and 2. Any question? Now we are ready to easily integrate it. So to bring this one down. So this integral is equal to double integral in polar form. R is between 0 and 2. Data is between 0 and 2 pi. Function e to the, you know that x squared plus y squared is r squared. So e to the negative r squared. Extra r, remember, extra r, dr, d data. If you miss extra r, then you can't find this integral. So if this integral getting complicated, probably you missed the Jacobian, that's r. Okay, now we are ready to do it because we are going to use, if you call this one u, your prime would be -2r. So a -2 is missing here, okay? So if you take your u to be -r squared, your du would be -2r dr. So I missed a -2 here. So what I do is I divide the outside by -2, 0 to 2 pi. So that's going to be 0 to 2. Now I have a -2r that I need. Okay, so it's going to be e to the -r squared, -2r dr. Okay, then the d data. So that's exactly what I need. I have the e to the u, du, which is e to the u. So it's going to be -half integral from 0 to 2 pi. So that gives me just e to the -r squared. R is going to be from 0 and 2, and then we done d data. Okay, question? So substitute, the result's a number, or number. So that gives you -half, 0 to 2 pi. If you put the 2, that gives e to the -4. Minus, if you put the 0, e to the 0, and the d data. Okay, you cannot do anything about e to the -4, just keep it. E to the 0 is 1. So you can pull them out, is a -1/2. E to the -4 minus 1, 0 to 2 pi d data. Integral of d data with the data between 0 and 2 proof would be just 2 pi. So it's a -half, e to the -4 minus 1. That gives you data to be evaluated from 0 to 2 pi. So it's going to be -1/2. E to the -4 minus 1 times 2 pi. Simplify the pi. So the final answer, you can multiply inside or just write it down as is. If you want to multiply inside, is going to be your result. So the integral is going to be equal to, if you want, you can multiply the pi inside, so that give you pi minus pi e to the -4, or just using your calculator, whichever method you want to get the final answer. Okay, so you have to consider the both conditions to see whether whether it's going to be a circle, a semicircle, full circle, to get to get this number done. Okay, so when you are going to be having it in this format, okay, when it's a circle, half a circle is not a big deal. The challenging one is part C. Okay, I quickly give an idea of the part C. Then the part D, you can, part D is similar. So C and the D are the challenging one. Okay, we're not going to test you on this, but we would like you to learn it, how you're going to check this type of it. It's kind of, you see, this integral you're just doing on a circle. Suppose you have a pizza. If you have a pizza, this is the situation that you have. You see the full pizza is a circle, half a pizza, semicircle. But sometimes when you go and order a pizza, you don't want to get a family pizza. So you just want one slice of the pizza. If you want to get the one slice of the pizza, this means the origin is going to be just, we call it a sector of a circle. When it's going to be a sector of a circle, that's something else for the polar coordinates, okay? It's a very unique problem. So I'm going to explain this one for you quickly, just for your information to know it. It's a very unique problem, and we don't usually question you on that one on the test, but you have to know it, okay? So let me show you how we're going to how you find this integral when you have just a slice of pizza. Okay, let's see what's going to be difficulty. So this would be what part? Part C, I think, yeah? That's a part C. And it's in every calculus book. They bring this one up because this is quite different. Let's learn. You say it's very good to learn this type as well. It depends on your future, in your discipline. You see, the polar coordinate happen in application problem quite a lot. So you may have to do a research something in physics, mechanics, etc. And you may have to do it. Okay, so we are going to prepare you. Not difficult, nice. You see, let me show you how nice it is. You see, this is a situation. You want to do it with the polar form. You see these terms? This is not a kind of a circle, semicircle. It's y equal to the x. Y equal to the x is just going to be just a line between 0 and 2 that give you that piece of pizza that I talk about it. So if you set up this region to do it with the polar, so let's set up this region. So what you have? You have the fact that your x is between 0 and 2. This is your x. Your y is between 0 and x. You see? So what type of region do you have? You have a rectangle. You see, in rectangular coordinates, this would be y equal to the x, okay? This would be y equal to the x, and this is y equal to the x. Okay, y equal to the x, and this is going to be 0. And if we put x equal to 2, you get the 2. So that's going to be the 2 and the 2. Okay, so in rectangular coordinate, the region is going to be a triangle. Okay, so if you go to the polar form, this rectangle would be just, because this is going to be a ray, if you like, we call it, in the polar form. So if you go to the polar form, this is the situation you're going to have. In the polar form, you know that in the polar form, you are going to have a data. So this is going to be your data in this direction. In this direction, and because of this point, you are going to stop somewhere. So this is going to be where you are going to stop, if you like. So you are going to get this sector of a circle, you see. This is just a curve. Pizza. You say it's going to be this pizza. And you have to describe it to get this, this true. So to describe it, you need to describe the R and the data. To see, that if it was just a quarter, that data is going to be between 0 and 2 pi. But it's not, it's just a slice of the pizza. So you have to know what is going to be data. And you take that share. So how small, how big it's going to be. So we have to investigate it. As usual that we did this type of problems. Okay, so let's find out what does it mean y equal to the x in polar form. So We work on it. This is y equal to the x. So if you substitute, this is r sine of the data, and this is r cosine of the data. You see? So data r is not zero, so you cancel it out. And you get the fact that the sine of the data is equal to the cosine of the data. And you know that this means you divide by the cosine that give a tangent of the data equal to the 1. And you know that the data is going to be equal to the pi 4. So that will tell you when you pick your pizza, what is going to be your share. So that will quickly tell you that you pick the pizza sector of a circle between 0 and pi 4. Okay, so you get a quarter of a pizza and then you quarter it again if you like, half of a quarter. So that gives you the restriction for the data. So your data is going to be between 0 and 2 pi. Any question? Now, what's going to be restriction for the R? You see, in the other course, or the other one that we did, this was a kind of since it was a part of a circle, so we'll be able to find that R right away, but not in this one, because this means you go 0 to 2. Okay, so there must be somewhere here, somewhere over here that you will get that x between 0 and 2. So we are going to work on this one to see what is going to be the restriction for the R. So if we work on this one, let x equal to 2, x equal to 2. Now you substitute, what is x? X is r cosine of the data. So that gives you r cosine of the data is equal to 2. Okay, remember you want to find something for the r, so solve for r. So that gives you 2 over cosine of the data. Okay, and you know, you can keep it as is or you can call it secant. 2 secant of the data. You see that gives you the restriction for your r. So in this case, r is dependent on the data. So this means your restriction for the r is going to be between 0 and between 2 secant of the data. You see, this is the situation you're going to have. So that portion that you're going to be interested in, you know, this triangle would end up with a sector of a circle that the data is going to be between 0 and pi 4. Okay, but r is going to be valid. R is going to be various in this form. Okay, any question? Now we can change the integral. So what was the original integral? It's a nice problem. These techniques that we want you to know it. And we are going to use it once in the spherical coordinate, or one problem in 3-dimensional. So this is the original one. Now we change it to the polar. So your polar is going to be r is between 0 and 2 secant of the data. Your data is going to be between 0 and pi 4. Function is easy because that was radical x squared plus y squared. So the function is radical r squared, Jacobian extra r, dr dθ. Okay, so it's not a big deal to integrate it. Again, this is going to be what? This is going to be r. Okay, then r times r would be r squared. So you are going to integrating this one. So it's going to be 0 to pi 4. Okay, 0 to pi 4, and this is going to be 0 to 2 secant of the data. And that would be r squared. Okay, r squared, dr dθ. Integral of r squared is going to be r cubed. So it's going to be 0 to pi 4. Okay, 0 to pi 4. And this is going to be r cubed over 3. Okay. So I need a new pen. So r cubed over 3, and this is r going from 0 to 2 secant of the data. And then when you're done, you come back and you say d data. Now, if you substitute, so that gives you 0 to, okay, you can pull out the 1/3 outside. 1/3 outside is going to be 0 to pi 4. But the resulted function is going to be 2 secant cubed. You see, it's going to be 2 secant of the data cubed minus 0, then d data. So that cube, 2 cube would be 8. You pull out the 8, 8 third, 0 to pi 4. What is this one? Good luck. Secant cube of the data, d data. You see, if you remember on calculus 2, if you want to find the secant cube of the data, d data, that's another challenge to find it. You have to use integration by parts to do it. Okay, so I'll just give you the result. That integral is the following: 8 third, okay? Integral of a secant cube is this. From calculus 2 is 1/2 secant of the data, tangent of the data, okay, plus 1/2 ln of the absolute value of a secant of the data plus tangent of the data. This is it. And you have to find it from 0 to pi 4. Okay, and if you substitute, if you would like to get the final answer, this is it. 8 over radical 3 plus 4 ln of radical 2 plus 1. This would be the final answer. Okay, this is a very popular problem in calculus 3, but you know, it would be too much for the test. But it doesn't mean that if it's not going to be on the test, we are not going to learn it. You can see you learn quite a lot for these type of techniques, and the aim is future. We may have to use it somewhere. So that's why we need, we need to know the discipline. The one that is going to be given on the test is symmetric, nice, circle, half a circle, semicircle. You'll be able to do it. But as soon as you get this one, you won't be able to do it. And it's a very unique problem. You can't see. If you check the old calculus books, you will see this. And the other one is part D is much more involved than this one. Okay, I can give you the solution of that one as well, but it's very similar to this, but it need more algebra because the inside is radical 2x squared plus x when you want to integrate. And that would be another problem. Okay, so this is just for fun, but you know it, the techniques, very unique techniques for the polar coordinates. Okay, any question? So I should give you one surface area. We have two problems. I've already done a very similar one for the first one. The area between two, you can check your lecture notes for number 11. I did the number 11, in fact, ln of the x squared plus y squared. So for number 11, directly check your, you see this is number 11. It's angular region that we did it. I did it over here, I don't know. Bing. Where is that number 11? This is number 11. Okay, the number are different. This is 1 and 5. I changed the 5 into the 4 to make it easier to integrate. Okay, so check this one for yourself. Yes, what's the question? To get this number done. Okay, on the test, will you tell us when we need to convert? Oh, yes, of course. Yes. Yes, we give you when to convert, change the reverse order and the polar form, but you may have to do the polar form yourself in the problem of the surface area. That it's up to you. But yes, we give you the instruction. We give you one problem using the polar coordinates, one problem using the reversing the order on this quiz, test, and the final. But there are a situation that you may have to use a polar form yourself. And that would be easily, can be easily found. Yes, that's it. We give you one of these. Okay, let me just, with the time that we have, I have to explain this. So that was number 10. Okay, that was number 11. Number 12, part 1, I did it the other day. So I do the part 2 for you. The part B. When I post this one for you, I put the solution of the 12A as well for you. Okay, so I have to do the part B to make sure you understand what we did the other day. Surface area, You see, surface area is a very nice example that in the course of finding the integral, then you have to do the polar form yourself for your for these type of examples, okay? But otherwise, the instruction would be given. Okay, there you are. Number 12, 12b, surface area problem. So one of those 6 questions is going to be surface area. Again, 1 for the quiz, 1 for the test, 1 for the final. So we want to find the surface area. You do the surface area quite a lot at the end of the course. Find the area of the surface. I write it down. I do the part B. Surface of the part. It's like very much like the one that I did the other day, because we don't have quite a lot. Of the part of the surface, this is the surface, 2y plus 4z minus x squared equal to the 5. Okay, that's the one. Again, it's that we are not going to let you go without triangle. Okay, that lies above. Right above the triangle. Triangle with the following vertices, okay? With vertices 0, 0, 2, 0, and 2, 4. That's it. Once more, it is a triangular one. We won't let you go without that. Okay, you know the formula, the surface area formula. That's it. A of S, area of a surface. Double integral, a kind of arc length type formula. 1 plus round z, round x, all squared, plus round z, round y, all squared, and the dA. That's it. So the function is given to you. You are going to make it as a z to be able to find this radical. Then you drop it in 2-dimensional. Depend on the region, you integrate it. Okay, so start with your function, change it to the z because you have to find this. So the function is 4y plus 4z minus x squared equal to the 5. Solve for z. 4z is 5 plus x squared minus 4y. Divide by 4 carefully. Z equal to 5/4, 5/4 plus 1/4 of x squared minus 4 divided by 4 would be 1. Okay, so did I make a mistake? That's a 2y. Sorry, that's a 2y. 2y. 2y, and it's going to be 2y. Okay, so this is going to be 1/2 of y. Okay, 1/4 of x squared minus 1/2 of y and the 5/4. This is your z, differentiate partial derivative carefully. Round z, round x equal to, this would be 0, 2 times 1/4. Okay, so that give you 1/2 of x. 1/2 of x, round z, round y. Round z, round y, just simply -1/2. Okay, put it here. So a of z, you can even simplify inside and then go to the radical. This is sometimes I do. So it's going to be 1 plus 1/2 of x all squared plus -1/2 squared. Then the dA. Simplify it. So that give 1 1/4 of x squared 1/4. 1 1/4 would be 5/4. So you get this one. So it's going to be a double integral over R, and this is going to be 5/4. 5/4 and 1/4 of x squared dA. You see, you have to find this integral. But the difficulty is you have to find it on a, okay, again, on a rectangle. The same problem. You have to construct the rectangle, get the region, and then you go for it. Okay, the region are mostly, easy, but I picked this one because there is one in your book. Okay, you just want to know it. So it's going to be doing on T. The T is this rectangle, 0, 0. Okay, 2, 0, and the 2, 4. Again, you have to form this one, get the restriction of the x and the y, and come back and do. You see, the difficulty is when you want to integrate this one, you need a kind of a 2x here, u prime, to be able to do it. And then you will get it from here. So let's work on the rectangle to see what's going to be the region that you have. Okay, so this is going to be a rectangle. You see, this is the third time that we do this. 0, 0, 2, 0, 1, 2, 2, 0, and 2, 4. That's a 2, 4, 1, 2, 3, 4. So that's a 4, 2, 4. So this is all your rectangle. You see, this is your rectangle. So this is the region that you're going to be concerned with. So in this region, as you can see, x would be between 0 and 2. And the y is going to be up and down. You see, up, down, up, down. So down is simply 0. Up, you have to find it. Not difficult to find because this is 2 and 4. Okay, you can find the equation of this line. It's going to be y equal to the 2x. Again, you have this slope. You see rise, run. The rise of the 4 and the run of the 2. So 4 over 2 would be just 2. So that gives y equal to the 2x as the equation of the line. That's it. Any question? So that was easy when the side of the ray is going to be along the x-axis, that would be easier to identify it. So there you are. We are going to integrate on this form. So that integral that gives us the surface. You see inside the radical, you did have the 5/4. Okay, plus 1/4 of x squared. Now you know how to handle it. Your x is going to be between 0 and 2. Your y would be 0 and 2x. Okay, and you know that you are going to do the y first and then do the x. Any question? So that make it easy, otherwise we can't do it. We integrate respect to the y. So this just would be a constant y. Nice. You see 0 to 2. Y radical 5/4 plus 1/4 of x squared. But y going from 0 to 2x. And when you're done, dx. If you substitute, that gives you 0 to 2, 2x radical 5/4 plus 1/4 of x squared. And if you put the 0, that gives you 0, nothing. You see, nicely, everything would come around. So you end up with this one, 0 to 2, 2x, change it, 5/4 plus 1/4 of x squared to the -1/2 dx. is ready for the U substitution. You see, you take this one to be U, you need the du. What's going to be your du when U is 5/4 plus 1/4 of x squared? Your du would be simply 1/2 of x. So you need the 1/2 of x. So, it's easy to create the 1/2 of x and be able to do it. So this is the way I do it. I need the 1/2 outside. Okay, or just go back and substitute to get these numbers. So I'm going to bring these two out first. And then you can do the direct substitution. This is the way I do it. So I need the 1/2 here. So what I do is, this is 2. I multiply by another 2. Then I go the inside. I divide by 1/2. But you can do the substitution. X times 5/4 plus 1/4 of x squared to the negative 1/2 dx. There you are. I have the u and I have the du. So this simply would be u to the negative half. 2 times 2 would be 4. So it's equal to the 4u 5/4 plus 1/4 of x squared, everything to the half divided by the half. So going to be from 0 to 2. Okay, because it's just a u substitution here. So reciprocal of the 1/2 would be 2. 2 times 4 would be 8. So we get 8 times 5/4 plus 1/4 of x squared to be evaluated from 0 to 2. I'm sorry, this is a 1/2 here. So, we just substitute, get the result. You may have to use your calculator, or maybe not. Because if you replace the x by 2, so I put it here to finish it. So if you substitute 2, so that give you 8 times 5/4 plus 1/4 times 4, 1/4 times 4. Then 1/2 minus, if you substitute 0, so that give you 5/4 to the 1/2. 4 and 4 would cancel out. You get 1 plus 5/4, which is 8 times 9/4 to the 1/2 minus 8, and that's going to be 5/4 to the half. You can use your calculator to estimate this one to give you the final answer. It's a very nice problem. The problem of the surface area, the integral, it's always, getting this type. So the region can be very easy one, it's a rectangular one, and we give you a straightforward numbers. But in this practice one, as I told you, this practice quiz is very, very deep, and then it's quite interesting. That you should learn quite a lot from reading these solutions, and after that, you should be able to challenge any problem of this part. But the problem that you see on the test are going to be shorter. You may see a couple of these, more involved, but that will give you all the application, because we have the triple integral. You saw the triple integral, just a double integral. You get back to this one. So study this one carefully. I post the quiz tomorrow, and yes, as usual, when you converted the square root into the exponent, it shouldn't be positive. Yes, it's positive. This one. When I integrated, that would be a positive number. That would be 1/2, then divided by 1/2. And then you can check it, the details, but
I'm sorry. I was talking about when you started doing U substitution.
yes.
Above where you have the bracket U.
Yes.
Above there. The one above that. That one right there, yes.
Yes. Okay. You see, it's u to the negative half eventually. U to the negative 1/2 would be U to the positive 1/2 divided by 1/2. When you know, whatever you do, the target, you see this is simply U to the, okay, this is you integrating U to the negative 1/2. So you add is going to be 1/2 over 1/2. Is it the one you talk about?
My question is because the square root was in the numerator. So shouldn't it have been a positive 1/2?
Positive 1/2. Oh, it's too late. You are right. Yes, you are right. Why I missed it? It's positive 1/2. Yes, 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 you are right. But it's too late. 1/2. Yes, you are right. Thank you. Yeah, you change it to the 3/2. You are right. Very good. Thank you. So this is going to be positive 1/2. And what change now? Positive 1/2. So this would be 3/2. 3/2. 3/2. 3/2. And the 3/2. Thank you. Okay, that's one. Yes, you are right. Okay, that's it. So get practice this one. Keep them for the next test and for the final. That would be very useful. Okay, that's it. Have a good one. And let me know if you need anything. Okay, I'll post the quiz tomorrow early so we can work on it. And then that will help us quite a lot to get through the last part of the course. Okay, so take care. Bye-bye.